Swayam Prabha. Digital India. Educated India.
Hello friends. So, in the previous lecture we have discussed regarding the digital implementation of the digital or numerical relay when we used in a power transformer. We have discussed that if we wish to achieve the inherent phase shift compensate, then we have to use different matrix depending upon what vector group or winding connections are used. And we have also seen that as per IC 676-1, we have to enter the winding connections, first HV winding, then LV winding, and then the phase difference of LV compared to the HV. And then we have seen that depending upon each or specific vector group or winding connection, specific matrix is available, and that matrix is need to be multiplied with either delta or star depending upon what degree of phase shift we want to cancel. Then we have discussed the overall diagram of the digital or numerical relay applied in for power transformer. So, we have seen that when we have the LV winding current and HV winding currents, after the magnitude compensation, phase compensation and zero sequence compensation, and after summing we will have the value of the operating current, that is the vectorial addition of two currents or two winding currents. Similarly, we can have the value of restraining current by just scalar addition and multiplied with the compensation factor k, in this case it is 0.5. Then once we have the value of operating current and restraining current, we can use these operational amplifiers and AND gate, and we can connect it in such a way that when operating current exceeds the restraining current, which is multiplied with some slope, and second when operating current exceeds some IPU value, then the tripping command is initiated by the relay and the circuit breakers can be tripped. Now, in this class we will discuss the two important problems that is faced by the digital relay or numerical relay, that is the transformer over excitation condition, and second is the magnetizing inrush current. When we switch on the unloaded transformer, then the magnetizing inrush current comes, and transformer over excitation condition comes specifically when there is a specific change in voltage and frequency or both. So, let us discuss first the over excitation condition. So, the flux in the core or transformer core is directly proportional to the applied voltage and it is inversely proportional to the frequency, and this can be seen using this equation. So, the flux in the core, that is directly proportional to voltage and that is inversely proportional to the frequency. So, if there is an increase in voltage, so in case of over voltage condition or in case of reduction in frequency or both over voltage and under frequency, in that case the level of flux inside the transformer increases and there are fair chances of saturation of the transformer core, and because of this fact transformer may be exposed to an over excited condition. So, in this case relay may initiate a wrong trip in over excitation condition, and this needs to be avoided by taking some precaution in the digital or numerical relay. Now, if I consider over excitation condition in a typical power transformer, then basically if I look at the waveforms of this over excitation condition, then you can see I have shown the primary current waveforms with reference to the time in terms of cycles, and if I take the harmonic contents of this current waveform, then you can observe that the over excitation condition is basically nothing but the AC saturation of the core, which produces harmonics and more specifically odd harmonics. So, here in the table you can see, if I take the harmonic analysis of this waveform, then you can see in the first column I have shown the frequency component, and in the second column I have shown the percentage of fundamental for specific frequency component. So, fundamental is obviously in the first row it is highest, but if you consider the third harmonic component, then its value is 49.2% with reference to the fundamental, and fifth harmonic value is again 21.7%, and seventh harmonic, that is almost close to 8%. Now, third harmonic we cannot use, because if I have delta connected winding, then that can be trapped inside. So, we have to go for fifth harmonic. Normally most of the manufacturers, they provide the over excitation blocking condition with the help of fifth harmonic content. So, if this content exceeds some threshold value, then the blocking command is initiated and relay should not trip, because this is not a fault condition, but it is an over excited condition of the transformer. The second problem that is faced by most of the digital or numerical relays is maloperation in case of magnetizing inrush current. So, we know that when we switch on or energize the transformer, and this energization of power transformer is very frequent. So, when we energize it, normally load is not connected. So, when we energize unloaded power transformer or lightly loaded power transformer, then in that case the wave shape of flux that is entirely different than it is in normal condition. So, when the wave shape of flux is symmetrical in nature, right, because I have shown the flux waveform with reference to the voltage waveform, because both are in quadrature. So, if your flux is symmetrical in nature, then this point you can extend it here, and this another point you can extend it here, and if you extend these 2 points, then you will have the value of current which is well within the range. However, when your flux is not symmetrical, that means when it is asymmetrical in nature, then you can see that this and this, there is an asymmetry. So, in that case you can see this point that will be extended here on the BH curve, because in earlier case if you see, I have shown the hysteresis curve where this operating point remains in the linear region. However, when your flux becomes asymmetrical in nature, then this point that is will extended, whereas this point remains as it is. So, if you extend these 2 points, then the magnitude of current that increases suddenly with reference to the full load current of the transformer, and this value of magnitude of current, that is almost 5 to 6 times the full load current of the transformer. So, because of that your transformer may damage. It may possible that your relay looks this as an internal fault and it may trip the circuit breaker. So, false operation of transformer that can be observed. Sometimes power quality is also adversely affected, and this inrush current contains significant value of DC component. Problems are also there because of this DC component, those are also observed when we have magnetizing inrush current during switching of